Friends, Namaste. This is Rajneesh Sawant and you're watching Janta Janardhan. In this video, we are going to talk about the term algorithm. Friends, be with me till the end of this video. We begin with what is an algorithm. An algorithm is nothing but a process or set of rules to be followed in a calculation or other problem solving operations, especially by a computer. One of the most common examples of an algorithm is a recipe. It's a finite list of instructions used to perform a task. For example, if you were to follow the algorithm to create brownies from a box mix, you would follow the 3 to 5 step process written on the back of the box. A recipe is a good example of an algorithm because it says what must be done step by step. It takes input, that is, ingredients, and produces an output, the completed dish. Informally, an algorithm can be called a list of steps. Friends, how to build an algorithm in 6 steps. Step 1, determine the goal of the algorithm. Step 2, access historic and current data. Step 3, choose the right model or models. Step 4, fine tuning. Step 5, visualize your results. Step 6, running your algorithm continuously. What are the 5 things algorithms must have? Input specified, output specified, definiteness, effectiveness, and finiteness. What are the qualities of a good algorithm? The characteristics of a good algorithm are 1. Precision. The steps are precisely stated, that means defined. Uniqueness. Results of each step are uniquely defined and only depend on the input and the results of the preceding steps. Third is finiteness. The algorithm stops after a finite number of instructions are executed. What are the key features of algorithm? 1. Input. A good algorithm must be able to accept a set of defined input. Output. A good algorithm should be able to produce results as output, preferably solutions. Finiteness. The algorithm should have a stop after a certain number of instructions. Generality. The algorithm must apply a set of defined inputs. An algorithm must satisfy the following criteria. 1. Input. These are the values that are supplied externally. Output. These are the results that are produced by the algorithm. Definiteness. Each step must be clear and unambiguous. Finiteness. The algorithm must terminate after finite number of steps. Should you learn data structures or algorithms first? You should learn data structures first. Algorithms are based on data structures. Data structures are easy to learn and include things like arrays, stacks, queues, etc., and then move to algorithms. Learning data structures is part of learning algorithms. Data structures should be viewed as a type of general problem solving technique in algorithms. That is, they are an important kind of building block for algorithms. An extract from Shilpa Jain's article dated March 4, 2018, like every invention has a necessity, and having data structures also had one. Say, you have to find a specific book in an unorganized library. You have to put in numerous hours in shuffling, organizing, and searching for the book. The next day, the librarian walks in, looks at the mess you have created, and organizes the library in a different way. Problem. Just like you can organize books in a library in 100 different ways, you can structure data in 100 different ways. So we need to find a way to organize our books, that is data, so that we can find our book, read again data in a very efficient and fastest way. What is the solution? Luckily for us, some Uber smart people have built great structures that have stood the test of time and help us solve our problem. All we need to know how they work and use them. We call them data structures. Accessing, inserting, deleting, finding, and sorting the data are some of the well-known operations that one can perform using data structures. There are two fundamental kinds of data structures: array of continuous memory locations and linked structures. In short, data structures can be defined as group of data elements which provides an efficient way of storing and organizing data in the computer so that it can be used efficiently. We can sum up data structures by saying that data structures provide a means to manage large amounts of data efficiently for use, such as large databases and internet indexing services. Usually, efficient data structures are key to designing efficient algorithms. In computer programming, a data structure may be selected or designed to store data for the purpose of working on it with various algorithms. The goal of data structure is to retrieve data efficiently from computer. Friends, let us see some of the advantages and disadvantages of algorithm. Let's first see the advantages. It is a stepwise representation of a solution to a given problem, which makes it easy to understand. An algorithm uses a definite procedure. It is not dependent on any programming language, so it is easy to understand for anyone even without programming knowledge. Every step in an algorithm has its own logical sequence, so it is easy to debug. By using algorithm, the problem is broken down into smaller pieces or steps. Hence, it is easier for programmer to convert it into actual program. Friends, let us see a few disadvantages of algorithms. Algorithm is time consuming. Difficult to show branching and looping in algorithms. Big tasks are difficult to put in algorithms. So friends, in this video, I have tried to put in basics about the term algorithm and to make it easier to understand. A special thanks to all those authors and various articles, Google and other encyclopedias that I have referred to make this video. Friends, in my next video, I will be talking about the term natural language processing. So keep watching Janta Janardhan. Stay safe, stay healthy. This is Rajnish Sawant signing off for now. Namaste.